Right. Assalamu alaikum. Can you hear me to the back? Are you even interested? Okay. So I'm from the math department. My name is Haniya Azam. I'm not going to teach any math. So I expect to see smiles on your faces here on. So let me congratulate you on being admitted. And also let me welcome you to SSE. And let me assure you at the same time that you're in good hands. And by the end of my session, I hope you'll be convinced, because the root cause of, well, okay, not the only root cause, but a big root cause of all the challenges that we face, all the challenges that we will meet in the future, all the innovation and creativity that they demand to be solved, comes from something that we love and at the same time we hate, and it's called mathematics. So SSE, the School of Science and Engineering, takes its mathematics very seriously. And this is, a string of all those changes, revamping, re-envisioning that we have been doing over the course of more than a decade in SSE, just to incorporate changes that are relevant and that can take us forward. Okay. So first of all, let me just say what the SSE core is. You've already had a session with the academic team in SSE. So you are already aware of what the SSE core is. So the first year is more or less, I should say, completely structured for you, which is a good thing, like we've seen in all the talks that preceded mine. You've seen a whole lot of interconnectivity, different fields talking to each other, interdisciplinarity, the scale, the magnitude, and the seriousness of the challenges that we face in the world today. They demand such an interaction between fields. So it's no longer biology not learning math, it's no longer math not learning biology, and so on. Okay, so it's a typical example because you've come right out of college and you face this question: is it biology for me or mathematics? Sadly or not, it's both of you for this year at least. Okay, so you're going to do biology and you're going to do a whole lot of mathematics. So part of this SSE core, which is your exposure to biology, chemistry, physics, electrical engineering, computer science, and of course mathematics, are 3 courses that you're going to learn in the course of your first 2 years, so your freshman year and your sophomore year. There are 3 courses that we call the math core. Okay, so all of you have to take this. And I'm here to talk about this math core. It's been in place since the very inception of SSE. And here are the 3 courses that students generally take. People at the back, are you able to read it? Or is it too? Okay, fine. So the first one is calculus. Okay. It's called calculus 1 because it has a sequel. It's called calculus 2 that you're going to learn in the next year. Not all of you, maybe most of you, but not all of you. There's linear algebra with differential equations. This is the second course that forms the math core. And then there's a third course on probability. Okay, so they're distributed in a way. It's good to have this in mind, that you're not the only ones who are going to suffer or take these 3 courses. The non-SSE students also take these courses. Okay, but most of you are going to take these courses in a certain order, in certain semesters, and the bulk of non-SSE students, may take them in other semesters because of their own course requirements and the way their degrees or programs have been structured. Okay, so calculus is calculus. You've gone through this boot camp already. Yeah, so where you're familiar with these symbols. Yeah, you've seen the concept of derivative, you've seen the concept of limits, and so on. Yeah. So this is really at the heart of all those equations that come out of these models, all these gentlemen have talked about so far. So anything, any phenomenon that you can model in terms of equations and where you need to log change, you need to study or change in that system, in a given system, you need to use calculus there. And then in the second semester, you take linear algebra, where we live in a three-dimensional world. Unless you're a string theorist, you might be living in a 10-dimensional world. But I'm not a string theorist, so I'm happy with my 3 dimensions. And so in this room, you see a whole lot of planes, 2-dimensional planes. Like this wall is a 2-dimensional plane. And then you see another 2-dimensional plane, which is the roof. And then another one, which is the floor. And you see that there is an intersection between the roof and that wall. And what does it give you geometrically? Can you recognize the shape? A line, that's right. So what you see in this picture over here are again 2D planes. They're like pages, out of a book. And you see these intersections between them. Yeah. So this point right here is an intersection between all 3 of them. Yeah. So that's one important aspect of linear algebra. Okay, just to give you a sense of. And then there's probability that you get to learn in the second year. All right. And this is really the mathematics of chance, where in systems which are not deterministic, you can't put a finger on a value or a computation. You need to factor in the chance of a chance that an event may occur. Okay, so that's where you need probability. And in this very somber backdrop of the floods that we're facing, for instance, the climate change and everything else, or any sort of calamity which is natural or man-made, we see that these models, if we tend to model these as equations or as a mathematical model, it's hard to have something that's deterministic. You cannot expect to have a black box where you give it an input and it gives you an answer back. Okay, so it's not as simple as that. So probability is really part of the core of math that each one of you must learn. Okay, whether you're going to go towards a discipline which has a bulk of biology or life sciences in it, or a bulk of chemistry in it, and when I say a bulk of this and that really means that we're really talking in interdisciplinarity here. Okay, and that's really what has preceded my talk as well. Okay, or my session. All right, any questions so far? Yes. Sorry? 101? We'll come to that later. We don't know 1-to-1 yet. Okay, we'll come to that later. All right. So while we've all talked about the need, so I'm not going to dwell too much on this. Okay. So what was the need? What was our philosophy? As I said earlier, we at SSE, we feel very strongly towards math. We take our math very seriously, and so should you. All right, which is what this session is really here for. So we've heard people talk very eloquently about changing times, global challenges. Of course, at the core of, first of all, understanding what the challenge is. That's the first thing. You recognize a challenge, you understand it, and then you look for a solution, right? You see here a picture of, these are like the components of intelligence. And it's like arranged in the shape of a brain, human brain. And you see the biggest component is creativity. So creativity, the next step comes innovation. So you have something already, you need to innovate better, improve it, adapt it to your own changing circumstances and so on and so forth. But of course, creativity is very, very important. And that's exactly what math does. When you get a question, if it's not out of your past papers that you know really well how to solve, you come across a challenge, be it on paper, and it's probably just affecting you and no one else. But it's a challenge. You look at it, you try and understand, you work your way around it. You start, you adopt an approach, you discard it, you adopt another approach, you discard it. Eventually, you may reach a conclusion, a solution, or something of the sort, okay? So this is creativity. Math or mathematical ability really feeds into this component of creativity, okay? So which is why we thought that, which is why we personally, at the school also feel that this is something important. And there has been of course, there's been a general consensus among all departments to better cater for major specific needs, which is why this revamping was very important. And the new math core, which I'm going to tell you in the next slide, it offers you a greater degree of flexibility. So as it is, like I showed you in the previous slide, you didn't have any options to choose from. You had this calculus, the linear algebra, and the probability course, right, which you had to take no matter what, okay? And of course, it offers you the opportunity to enrich your mathematical ability, which I was talking about earlier. Okay, so what's different in the new SSE math core? So we've introduced courses into different streams, okay? So there is one stream that we call the general stream, and there's another stream of courses that we call the honors stream, okay? So do not mistake this as, getting 2 different degrees or a mention on your certificate or something. It's the same degree, it's the same program, just that you have now 2 different streams of courses, of math core courses that are being offered, okay? So all other SSE core components, your exposure to EE, CS, life sciences, chemistry, and so on and so forth are going to stay the same. So Calculus 1, for instance, will be offered in 2 flavors. It will be called the same, Calculus 1, and the other one would be called Calculus, I forgot the one here, Calculus 1 Honors, okay? And similarly, 2 flavors each for linear algebra and probability, okay? So let's just see what the course distribution looks like. You might want to pay some attention to this. So this is your freshman fall, this semester that's coming up next week. You have from the general stream, we have sections being offered for Calculus 1. We have one section being offered for Calculus 1 Honors, okay? And in the following spring semester, you'll be taking this variant from the general stream that's still called linear algebra with differential equations. And this variant from the honors stream, which is now called linear algebra 1 honors. There was a question about math 121. You see here math 120H. So the one that was called math 121 formally is now called math 120H. Okay, so that's linear algebra 1. So it's just a variant of the one that's being offered in the general stream. Okay, so that's the course distribution. And so let me just say a word before we move on about this linear algebra with differential equations. So here you see a mention of differential equations. In this course, we have like about 4 or 5 lectures worth of differential equations as well. Okay, apart from linear algebra, and here we do not in the honors stream. The reason is because there is a different goal for linear algebra 1 and there's a different goal for linear algebra with differential equation. And I will explain in a moment. Let me just go over this table once. And the fall of the first semester of your second year, which is fall sophomore year, you will be taking the sequel to calculus, which is calculus 2. This at the moment does not have two variants. It's the same for everyone. Okay, it's going to be core for some majors and not core for others. And then in the same semester, you will also have the opportunity to enroll, if you like, into the introduction to differential equations. So you're not losing anything if you enroll in linear algebra 1, because in the next semester, you have the opportunity to enroll into an introductory differential equations course already. Okay, so what are the differences? So the difference is, let's talk about freshman year first. The difference is that in calculus 1, we give you more breadth of the subject. Okay, here we'll be adding, we've basically revamped the older outline, the older set of topics that we used to teach in calculus 1. We've extracted the more, some formal aspects, some formal math, which was the formal definition, for instance, of limits. Okay, so we've extracted that. And in place, we've added some applications. Okay, and we've added a very easy differential equation, the concept of differential equation, and very easy differential equation that you can solve with the tools that are given to you in calculus 1. Okay, so that's the revamped Cal 1 course. And in this course, you will see the formal aspects as well. Okay, so for instance, the Riemann integral, which I don't expect you to know at the moment, of course. You will also see the formal definition of limits. It's called the epsilon delta definition, and so on. Okay, so you'll be exposed to that in the honors version of this course. And I've already explained what the difference between linear algebra, differential equations, and this is. Apart from the fact that linear algebra 1, again, has more tilt towards, the formal aspects of the course. And this is also a somewhat proof-based course. So what does that mean? That means that you will be not only just exposed to formal proofs, mathematical proofs. So you've seen this shift Dr. Bassett was talking about from college education to university. You have a goal of grades, in the college system. You have a set of past papers to solve. You have none of that now. Okay, so now your goal is to plug in all the gaps in your understanding that you had before, and to advance your knowledge. Okay, so before this point, of course, you've never seen mathematical proofs. Yeah, sometimes you have also not been taught, or you haven't learned why something is the way it is. Okay, so that's the difference from here on. Okay, so you'll be learning more proofs in this linear algebra 1 honors variant. All right, and then this probability is the third course. Again, more or less, I can say the same between the difference between these two, but here in this spring, you will already, majority of you would have chosen your majors by then. Okay, so you can make a better informed decision whether you want to take this variant or that one. Okay, but you will learn along the way. All right, so the good thing is, what if you make the wrong choice? The good thing is that anyone can take them. And the good thing is that you have this added flexibility that you could actually make your own set of combinations. You could choose to go for the general Cal 1 in your first semester, and you could choose to take linear algebra 1 from the honors stream in the second semester, and then go back to the general stream, or vice versa, or take two combinations of this or two combinations of that, and then take the other one for the third course. Okay, but this third course choice will probably be more informed. For you. All right, so who are highly recommended to take this course? These courses, the ones that come from the honors stream, of course, math majors, students who let's say for the moment want to.
How long would this for?
I just have to take some questions from them after this. I don't think I have any slides after this.
We can हम कर लेते हैं फिर उसके बाद questions कर लेंगे ये slide
अच्छा slide तक करूँ and I,
question भी
perfect. This should take maybe 2-3 minutes. Okay, so who needs to take these courses? Math major. So if you again, Professor Sabine, he advised that you should come in with a clear head. Okay, don't make up your minds yet. Okay, but you may think that okay, these are the 3 or 2 or 4 options that might be my choice of major. Okay, so if those choices lie here, then you're highly recommended to take the honors variants of the courses. Okay, and of course this is a recommendation. This isn't compulsory. So, and I told you that you have this flexibility that you can switch between the 2 streams as well. So it kind of works. Okay, so I think I can stop here and maybe I can just give you a recap later on when we open the floor.